Merge sort algorithm. So this is a question which I wanted to solve, which is related to merge sort, or it is a divide conquer approach. It's a very important question because usually they ask the algorithms of merge sort. So I will be letting you know the basic idea and basic algorithm of the merge sort. Basically, if you see, this is an array which we have it. The array consists of 7, 3, 2, 16, 24, 4, 11, and 9. Now, what is merge sort? Merge sort is nothing but divide and conquer approach. So, over here, when we are doing a merge sort, we have to sort simple. What we have to do is we have to sort this particular array in an ascending format. So, if you see at the down, you will see the array has been sorted in an ascending format. But how it is done is by divide conquer method. So, the array has been taken and it has been divided by it has been divided into two parts, that is the left array and this is the right array. So now this dividing of that particular array is done till we get one element. That means now once this entire array is divided into two parts, and those two parts are called as left array and right array. Again, this left array, if you see, this left array has this four integers, right? It doesn't have one element. So again we are going to divide this array again in the left part and the right part. So this dividation, if you observe, this dividation is done unless till we get one element. So see, now this is the left part, right? Again this array is divided and is divided into two parts, that is the left array and this is the right array. Again this array is divided into two parts, left array and right array, and same thing is done at this right side as well. And this, if you observe, this is the dividation, the purple line is dividation. If you observe this entire concept is dividing the array. So what exactly you're watching, that we are dividing till we get one number, we get a one element. And what exactly is this, like we are repeating those steps, right? And how we are repeating, we are solving one sub problem. So what we exactly did is we tried to solve the first problem. Like for example, like we solve we solve first this bigger problem into sub problems, right? Again this problem is solved into sub problems, again this is solved into sub problems, and the steps are repeated. That is nothing but a recursion, the solving of sub problems, solving solutions for the sub problems and repeating the same steps again and again is called as recursion. So we are going to use recursion over here, and this is the first part which I showed you is called dividing of an array into two parts. That is what is the recursion. That is what we are doing, the recursion. Now let's focus on merging, how to merge this array. So if you observe, this is a left array, this is a right array, right? Now what we are doing is we are going to merge this in such a format that a smaller number comes first and larger numbers goes behind, in then ascending format. Now if you see here, we have again merged the array, here also we have merged the array. If you see, 2 came first and 16 is later. Now what we are doing it for our simplicity, we are taking this as a left array and right array, and then let me just take another red color. Okay. So now what we are doing is, oh, so what we are doing is over here, this is our left of I and this is our right of J. So this is our left array, this is our right array. So we are always comparing left of I versus right of J. And whichever is small, right? Whichever is small, we are putting that as a first element in our next step. So we are comparing I and J, and whichever is small. So we have taken the two and then this is done. Okay, this is completed, so 2 went over here. Now we are moving our pointer from 2 to 16, but our 3 pointer remains at the same side. I pointer remains at the same element because we didn't do anything related to 3. Now the comparison will be between 3 and 16, and whichever is smaller, that we are putting into the next index for our merging concept. So basically we are comparing I and j, whichever is smaller we are putting the first, and then we are iterating to the next pointer. The pointer is iterated to the next number, and then again we are comparing that iterator which is at a next pointer versus which is at the original pointer, and then we are putting the smaller numbers. So this same steps which I told you over here will be repeated for the right array, and at the end we get a merged array which is in a sorted format, So if you observe, as I told you in the dividing, same thing if you observe in merging also, we are using the same concept, that is we are merging it here also, we are merging here also, we are merging here also. We are solving small problems and then trying to come to a conclusion and repeating those steps. That is nothing but merging is also using the recursion method. So recursion is used both for dividing as well as it is used for merging concept. Now, this is what is merge sort, basically dividing and merging this. Now, what is the time complexity taken for this? So, time complexity wise, if you see, dividing takes O of log n. Why O of log n dividing takes? Because we are dividing into two halves, right? We are dividing into two halves. So, it takes a time complexity of O of log n. That is for dividing. And for merging, it is like we are just merging those, we are not dividing, so it is just O of n time complexity. So total time complexity is O of n log n. So total time complexity is O of n log n. But did you observe that time complexity is O of n log n? We understood. What about the space complexity? Here, space complexity, it is taking O of n because we are, we at the first step itself, I said that we are going to have the left array and we are going to have a right array. So that's the reason the space complexity is O of n and time complexity is O of n log n. Let's start coding this particular thing. So we have a merge sort public static void merge sort int array. First thing first, I'm checking if array dot length, we have to do this merge sort only if it is greater than 2, right? I mean, if it is less than 2, then how are we going to divide it? We are unable to divide it, right? So this is just a base condition. Next thing is, as I've shown you in the diagram, we are finding the middle of the array. So I'm finding the middle of that complete array. First step is this. Then I'm going to initiate the left array. So new and here. So let's understand what will be the length of the left array. If you see the diagram which I showed you, this left array, this is left, right? And this left is till the middle. If you see, it is till the middle. So my length of the array will be till middle. So let's code that way. Then I will be iterating I equal to 0, I is less than middle, I plus plus. So I'm iterating the left array and then I'm assigning left of I to array of I. Simply, I am just inputting the array of I, first value of array of I to the left of index of 0, so that I'm just assigning the, I'm creating the left array basically over here. Now let's try to next step is, once you create middle left, then I have to create the, I have to initiate the right array. So let's do that. New int. Now here, what will be the length of right? Okay, let's try to understand. If you see this right array, obviously starts from middle, and it is altogether till array dot length minus 1. So, sorry, array dot length. So how we are going to do it? What we are going to do, entire array is array dot length, and we are going to cut this middle. Array dot length minus middle will be the length of right array. This is an complete array dot length, and I'm going to subtract this middle, so that whatever the pending is my length of the right array. That is what I'm going to write it. Dot length minus middle. Now, let's take the next step over here. Here, right, I will be having this I at middle value, because I'm going to start with the middle, right? As I showed you, I'm going to start with the middle. So just writing that. Now here, what will be the right of I, right? So right of I will be the first one, which is at the 0th index, will be I minus middle. That means, see, I, here if you see, I is middle. So if you see middle minus middle is right of 0, right? Here I'm introducing I as middle, right? So if you do right of middle minus middle is 0. So right of 0 is, right of 0th index is my middle, array of middle, right? Array of I. That is, it starts from the middle value. Now the same thing, whatever we did here, we are going to repeat the same steps. That is what we saw. That is what I'm going to do it. More sort left, more sort right, and then this is called dividing of the array. Next will be merging of the array. Merging of the array, merging left, right, and result. I'm just taking one array which is named as result, so that we can use that for our implementation of merging. Or you can take, let's take that in this fashion. Create method. Take, let's take result as well. Once you take here, I think I can write this way. Here, uses array. So just this array, I'm taking it over here, and that only array, I'm taking that as a result. I'm going to form that as a result. So let's see, we have this merging. We are going to do the merging. I'm just now going to initiate, initialize the variable in I equal to 0, in j equal to 0, and in k equal to 0. So now what I'm going to do is, while I is less than equal to left dot length and j is less than equal to right dot length. Okay, what is over here? Simply we are saying our left of I value. If you see in my diagram, I told you that this left of I will be comparing with the right of j. And if this is smaller, then I'm going to assign into my result array. This is my result array, and I'm assigning that into my result array. That is what is the step I'm going to define it. While this is the case, and while I is less than that of j, if left of I is less than right of j, that is what I told you right now, what I'm going to do is result of k plus plus equal to left of I plus plus. So I'm just checking whoever it is less. If left is less, then I'm inserting that left of I to the result, and I am incrementing the index. Same, I'm going to increment the result index as well. If this is not the case, then what is the case is result of k plus plus. If that's not the case, then I will be assigning right of j plus plus. If this is not the case, then I will be assigning j plus plus. Next is, these are the, if with this loop all are done, we are good. But if any other cases are pending, if still there is something like only at the left array and only at the right array, then we will be using the steps where I is less than. I'm just checking, is there any left over? If yes, then this loop will be coming into picture. This is not a important loop, but always, always you have to write these as a base condition, because the thing is, I'll tell you why I'm writing this base conditions. These are very important. I mean, according to the interview point of view, these are very important base conditions. So what I'm just saying is, so over here, see, over here, if this array was like even array, right? It was an even array, so you was able to divide in a proper format. But what if this array was not even? Already you have one more number over here. This is 9, right? So if you have over here, you have 10 number, and this is the array, then again you will divide it. That will be fine. But when you are merging it, then one of the number will be remaining or will be pending. So for to count that number, we are using these two steps, that if I is less than left dot length, then what we have to do, and if j is less than right dot length, then what we have to do, we are just assigning it into our result array. And this is all about the merge sort, O of n log n time complexity, and the space is O of n. Thank you for watching.